So in problem 2, it says on the D4 video assignment, we determine the exact area under the curve for f of x equals x squared on the interval from 0 to 3. Now they want us to express this as a definite integral of f. So before, what we did is we took the limit as n went to infinity of the Riemann sum. So the definite integral says we go from a to b, our function, times dx. So this is very important. This is telling you what the variable is, so this has to be here. This is the function, and these are the bounds on the integral. So to go from 0 to 3, our function is x squared dx. That's all we have to do for this one. Now it says, on number 3 says on D4, we determine the exact area for 2x plus 5 on the integral from 0 to 5. Express the area as the definite integral of f. So we said we go from 0 to 5. Our equation is 2x plus 5 dx. And since we know the area of this guy, we actually calculated it from 0 to 3. I'm going to grab my D4 key real quick. Back in D4, when we took the limit of this function, when we did x squared, we saw that we actually got 9. So we can actually go ahead and write in that we know that this will evaluate out to be 9. When we did the integral of 2x plus 5 from 0 to 5 and took the limit of the sum, we saw we got 50. So this integral will work out to be 50. Then we said we did the integral from, we estimated the area under 5 minus 2x from 0 to 2. So if we write out an integral for this, it's 0 to 2, 5 minus 2x dx. Notice for these last two, I had to put the expression in parentheses because all of it lives inside the integral, and the integral doesn't end until you specify the variable. And we actually saw a couple of different ways that this area worked out to be 6. Now it says determine the net area between f of x equals negative x squared on the x-axis and on the interval 0 to 3. So I'm going to first set up the integral, so from 0 to 3 of negative x squared dx. Negative 1 is a constant, so I'm allowed to pull that out front. Now, if I look at my answer from 2, we see that we already know the integral from 0 to 3 of x squared is 9. So I can come back down here and say, well, this is negative 1 times 9, or negative 9. The last one, we want to take an integral, or excuse me, a limit of Riemann sums. So we see it's 2 times c sub k times 1 minus c sub k squared, delta x. The limit as that goes to infinity is the exact area of some function x from 0 to 3. And now we want to write this as a definite integral. So the first thing that I can see is that my Riemann sum is delta x times f of c sub k. So that means I'm going to deconstruct this. So f of c sub k was 2 times c sub k times 1 minus c sub k times x squared. And that implies that f of x is probably 2x times 1 minus x quantity squared, because that's what we would do. We would figure out what c sub k was, and then we would plug it into the function. So now my integral from 0 to 3 of my function, 2x times 1 minus x squared dx, is our definite integral.